All right, so combinations. What I need you to realize about a combination, it's like a combo when you go to McDonald's. Raise your hand if you got to get. That's probably not good English. That's okay. If when you were little, you get Happy Meals. You have some choices with Happy Meals, agreed? You could get the chicken nuggets, you could get the hamburger, you could get the cheeseburger. You also can get, little known fact, you can get pancakes. There's a pancake Happy Meal. So you had to pick between those. Who's going to pick hamburger? Who's a chicken nugget person? Oh, we like the chicken nuggets. Who would pick pancakes now that you know you could get pancakes? They're very good. Anyway, so that has to go in the bag, agreed? Or in the box. Now, my children's super annoying. Everything has to be plain. So they like to get the hamburger and the cheeseburger, but usually it has to be made special because it's got to be plain. So when they start to build the box, they also have to put in there, do you want fries or do you want apple slices? And then you have to decide, do you want to have a toy or do you want to have a book? And do you want to have regular milk, chocolate milk, apple juice, or pop? Does it matter what order they put the things in the box in? No. There's lots of different combinations we could have, but they're going to just put things in the box. That's a combination question because the order doesn't matter. So I just want you, I don't even think you have this title, but a combination order doesn't matter. Order does, however, matter in a permutation. So your first job, every question you encounter, is to look and decide, is the order going to be important here? So the number of different ways 7 basketball players can be seated on a bench so that 2 specified players are always sitting side by side. This came out of yesterday's homework. Anytime they're forcing 2 people together, what do I want your brain to think? Sticky note. So we're going to call it player A and player B, maybe Alfonso and Bruno. They got to be together. Would you agree? In this situation, it's 7 players. The other players, they're all unique, special individuals. So I might even write this out. You could write it out as 1, 2, 3, 4, 5, 6, 7, but I like to go letters. Do I have 7 different letters there representing my 7 players? What is the first part of me creating my equation going to be? How many sticky notes do I have? 6. So would you agree it is 6 factorial for how many ways I can distribute my sticky notes? But then we look on the sticky note. Can those players flip-flop? 2 is the only number that you can write just as a 2 or as a 2 factorial, because 2 factorial is 2 times 1. So you would take these, you would crunch the numbers, maybe grab your calculators out so that you can remind your brain, where do you find that factorial button? What are we getting as a solution? Yes. Good. Find my page here. Oh, wrong page. There we go. 1,440. So kind of your code word there, because truthfully, you have to break these into code word, is the always sitting side by side, which made me think. Sticky note. Yes. Would you only ever do this interactive thing if they have to be in a certain order? So the subtraction, like when it's so there's 7 players, so you do 7 factorial, and then you take away. Okay, so if they said, I like this, would you like to do a subset question? Yeah. The other question we could ask, and it would actually be a better question, so if I was rewriting the AVP, I would do this. I would say part B, the 2 players cannot play together. So I would say that this one's probably even more common of a scenario to come up because it allows me to test 2 things at once. If they say the word cannot, I want your brain, or can't or isn't allowed, you want to instantly take the total minus if they are together. So that would be where we would take our 7 factorial and subtract our 6 factorial, 2 factorial. And that would be, it'll always be a permutation question, those kind of ones. But kind of nice because it allows me to do 2 different calculations at once. Is that good? So your total or your keyword there is the cannot or some version of that. So a permutation, and I think I wrote this in your booklets. If you look and find your combinations page. Yep, so if you go to your combinations page, you can fill in these blanks with me. A permutation is an arrangement of elements in which the order of the arrangement is taken into account. It is denoted NPR. So that just means on your calculator or on your formula sheet, because there's a formula for that, it would be NPR. Common scenarios of a permutation where order matters. What are some things you can think of where order is going to matter? This is in the paper booklet, yeah. Sorry, in your paper. So what are some scenarios we've seen over the last few days where order matters? How about making words? So an example would be making words. Because you're arranging letters and order matters. What are some other ones that you've seen in the homework? People in order. And I'm going to say people are objects in order. Now, it's important that we say that they have to be in order because there are going to be scenarios today where the order doesn't matter for that. So, for example, today I'm going to say, all right, I have all of you in my class. I'm going to choose 4 of you to come on a field trip. Does it matter which kids in which order I pick if everybody gets to do the same thing after I pick? No, I could say Casey, Kale, Hardy, Maida. They all get to go. Agreed? Even though Casey got called first, does that make Casey extra special? So that's a combination. But if we're putting them in order, if I said I want to line those 4 people up to do a picture, then I have something that's in order. Make sense? What's another one that you've seen? You liked these ones. License plates. Because the order of the letters or numbers matters. The other one that's fairly common is a lock combination. And the reason I always think this one, when I say combination, you're like, oh, that's a combination. But it's not a combination because would you agree in a lock, the order matters. So maybe we say lock code, I guess, because the order matters. All of those, the order matters. Now, a combination is going to be a set of elements in which it does not matter. It's denoted, and it's in your calculator, as NCR. N is still the total number of things that you're selecting from. R is still the number that you are selecting. But this time it's a combination. Your calculator knows the difference. Knowing the difference between the two is really, really important. That's the first step in any question because after today, it won't always be me telling you this is a combination or this is a permutation. So when order doesn't matter, we use combinations. If order doesn't matter, do you think there's going to be more possibilities or less possibilities? Okay, let's think about it. If I'm making the Happy Meal and I'm just putting things in, does it matter that it goes burger, fries, chocolate milk, toy? Or, so if you're telling me permutation, you're telling me that toy, chocolate milk, burger, fries, and burger, fries, toys, chocolate milk are both possibilities. But if it's a combination, you end up with the same thing in the end, so it only counts once. So a combination is going to create fewer or less answers than permutations. So when you have that, I'm going to get you to flip to page 397. Two different things. There is a formula for that, and the formula is going to have an extra thing on the bottom that actually is why we create less. So the formula will be n factorial over n minus r factorial. But notice we're dividing another piece out. So that's what's creating fewer. You have an NCR button on your calculator. There is one other way that they write a combination. Students every time are thrown off by it because you look at this and you go, it's got an N, it's got an R, it's in a weird bracket. Oh, they just forgot the fraction line. But they didn't. They did this on purpose. This is another way of showing a combination. And like just to jazz things up. But so you want to look at that when you think they forgot the fraction line, they didn't. It's just going to be a combination. And you could rewrite it then as NCR because probably if they write it like that, you're going to think it looks weird. So class example number 1 is the same scenario I talked about. 3 students in a class of 10 are going to be chosen to go on a school trip. So I've got my bucket of names. There's 10 names in the bucket, agreed? I'm going to pull names out of the hat. The 3 names I pulled get to go on the trip. Does it matter what order I pull the names out in? No, everybody gets to go. So in how many ways can they be selected? Now, if I want to know the way that they're being selected, is that suggesting that they want order to matter in this part? Yeah, that's the weird part. So how many ways could they be selected? This right here is telling me in what order could they be selected. So this one's kind of weird. If I was going to write this out, I would say, okay, we only have 3 names. How many names could be first selected? 10. How many names could be second selected? And how many names could be selected third? 8. So 10 times 9 times 8. They asked me to evaluate, so that would be 720. But they also want it written in factorial notation. That's weird, agreed? What does factorial notation mean that I should see? Exclamation points. What do you think the first chunk has to be to make it go 10, 9, 8 or start at 10? 10 factorial. Would you agree it does not go on forever? So something had to be after that 8, and the same thing had to be on the bottom. What would come next after the 8? 7 factorial, but would you agree to get that to cancel out? It's going to have to be 7 factorial. Are we okay with that? Now, they did not ask me to write it this way, but I'm also going to write this as a permutation. They asked how many ways can they be selected. They're telling me that the order matters then, so I could write this portion as a permutation. How many people did I have to choose from? Would you agree there were 10? How many did I choose? 3. Can you write now on your calculators? Press a 10. Go to your math button. Go over to probability. Pick the permutation. Pick the 3. What is it giving us? Are we getting the 720? Okay, I just looked at my answer key, and I read it differently when I did it as my answer key. Oh, are we all right? I'm going to reword this. It will be more obvious than this question was. When I read in how many ways, I read in how many orders. Can you cross this out and write the word orders? I read this one as a permutation, saying in how many ways, like who could be picked first, who could be picked second, who could be picked third. If I just wanted to know how many combinations of students there could be, and I used the word combinations, would you agree that's going to be a not, or order doesn't matter? So if we were to do this, we're just going to cross out B, and we're going to say how many combinations of students could be taken. Here I would say the order doesn't matter, and I'm going to teach you guys to do this one straight up from the NCR. How many students do I have to choose from? 10. So if the order doesn't matter, would you agree it would be 10 and I'm choosing 3? Can you enter that into your calculator? I think you should get 120. So that's the difference. You have to decide, and I don't like how they worded this one, so it's going to be worded cleaner on a diploma or on a test. But if I'm insinuating that we're just picking kids, would you agree it's a combination? But if I say in how many orders, meaning who could go first, who could go second, that'll be our permutation. So if we look at class example number 2, this is maybe the most famous combination question that you can get. To win the Lotto 649, a person must correctly select 6 numbers between 1 and 49. Jasper selected 6 numbers from the birth dates of his family, 3, 7, 9, 11, 20, and 29. How many different selections could he make? Have we seen this? It used to be on TV, but I'm old, where the ping pong balls pop up and then they keep the numbers. Order doesn't matter. It just matters if you have the right numbers. So would you agree if order doesn't matter, it's going to be a combination question? Now, there are how many numbers that you can pick? Matea hates this. Matea's going to count it on her fingers. If it goes from 1 to 49, there are 49. If it goes from 0 to 49, there are 50. So would you agree there are going to be 49 numbers you can pick from? How many are you picking? 6. Do we get where the word 649 comes from? It's a combination. Okay, I want to know how many potential selections could be made or how many potential tickets could be printed. You won't know this without typing it in. And it's gigantic, isn't it? Are you getting 13983? 816. So even if this is my career plan, is to win the lottery, do I have a very good chance of winning the Lotto 649? No, there is one winning ticket out of almost 14 million ticket combinations. Could it happen? Yes. Here's hoping. Okay, well, what about if I make up another one? So this one, I know I'm being a little bit wild today. It's back in your paper booklets. To play the Super 7 lottery, you must choose 7 numbers from 1 to 47. How many different selections and numbers are possible? So the word selections means I don't care about the order because we're just choosing or picking numbers. Anyone brave enough to set this one up for me? Matea? Good, 47C7. I wonder if the chances are higher or lower. So you get your handy dandy calculator out. I believe you're going to get 62891499. And I go back and I realize that's 62 million possibilities. Do I have a very good chance of winning the Super 7 lottery? Is this why you need to stay in school? Yes. Okay, should we try another one? The Athletic Council decides to form a subcommittee of 7 council members. Anytime they're talking about a council, everybody is going to be equals. Good? So does it matter who comes first? No. So to look at how funds raised should be spent on sports activities in the school, there are a total of 15 athletic council members, 9 males, 6 females. The subcommittee must contain exactly 3 females. Determine the number of ways of selecting. So selecting is the idea, it doesn't matter what order I'm using, just the females. Well, the females, how many are there that I am selecting from? 6. And how many am I going to select? It must consist of how many females? 3. So 6, choose 3, which I would grab out my handy dandy calculator for. And I would realize that there are 20 different options for that one. But would you agree if my subcommittee has to contain 15 members, I'm going to need some males on the subcommittee as well. How many males am I going to be there's a total of 15 members, but it's a subcommittee. So I know the subcommittee is going to have just 7 people. How many males am I going to need? 4. How many do I have to choose from? 9. So lots of times I actually read this as 9 choose 4. I get it. It's technically a combination, but when I see the C, I remember it's just choosing. And 9 choose 4 tells me how many combinations are there. 126. Now we have to decide. It's either going to be an and or an or. If it's and, would you agree we multiply? If it's or, we add. Does the committee need females and males or females or males? And. So when I see the word and, I know I would take those 2 numbers and I would multiply them to figure out my entire subcommittee, which is going to be 2,520. Now, lots of times, what'll happen is they're not going to break it into these parts for you. So if they just said, how many ways can we make the subcommittee? What you would probably write is 6, choose 3 in a bracket times 9, choose 4. That's the notation that they're going to use, where you're just accounting for both and you're showing you're multiplying with the brackets. Feeling okay about that? But then, Bruce, the football coach, who identifies as male, which they would tell you, has to be on the committee. He's in. All of a sudden, would you agree our committee needs to have Bruce? It still needs to have 3 females. How many males does it need to have? So we originally had, so it's down to just 3, because would you agree Bruce would fit to be that 4? So, and 3 males. Now, because it's an and situation, Bruce and the females and the males, what am I doing with those 3 combinations? I am multiplying them. How many Bruces are there? 1. Now, the females, I still have 6. I'm still choosing 3. Where it gets a little dicey is in the males. I no longer have 9. Because would you agree we reduced the number we're picking, but we also took Bruce out of the ones that could be selected? How many do I have to choose from? 8, choose 3. Very good. Can you take a moment, type that into your calculators? You probably don't need to type the 1 because we know 1 times anything is just going to be 1. And we are going to end up, I believe, if you crunch it correctly, with 1,120. Is that what we're getting? And does it make sense that because we put the restriction of Bruce on there, it reduced the total number of other ones? Not horrible? Now, super duper good news. Cards are no longer something that can be tested on the diploma. So I'm not going to test you on cards. It's really, really important that the diploma tests your math abilities. So it has to be something that you guys are super familiar with and that we could predict that all students would be familiar with. A deck of cards, once upon a time before phones and everything were a thing, we played cards in high school. Everyone did. But Kayla, I'm old. Yes. Fully understand. So we understood that there were 4 different suits and that each suit had a ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. We understood jacks or spades and clubs were black. We understood that hearts and diamonds were red, all of those things. Now, that's not necessarily common knowledge. If they were going to give you a question, they would then have to make sure that they provided a visual for you of all of the different things so that you could just pull it out of the picture, the information. There is also, and it comes down to just making sure that you're being culturally sensitive. There's some cultures who don't believe in deck cards because of its implications with gambling. So it is not something that will be tested. Good news for you guys. I actually love these questions on the diploma, the perms and comms, because they have to come up with really neat ways of applying it to something that everybody knows. Now, that being said, you cannot get to the diploma, see a Ferris wheel question, be like, don't know what a Ferris wheel is, can't answer the sinusoidal function question, because everybody should have been exposed in class to a Ferris wheel. Good? So you can't say, I don't believe in Ferris wheels. So we are going to, well, you know what? We're actually going to do this one because we haven't done that many. And we're going to fight through it together. But do we understand that? So the information's here. I'll help you. In poker, which you can play for fun, you get 5 cards in your hand. Okay, that's what you're holding. If I just want to know how many different 5-card hands I could get, what's the total number of cards in a deck? 52. How many do I need to have in my hand? 5. This is the same as Go Fish. Do you guys like Go Fish? Yeah, who doesn't like Go Fish, really? Does it matter what order I pick up the cards in? No, they still just end up in my hand, so this would be a combination question. So would you agree 52 choose 5 would give us our total number of cards? And it's also giant. It's in the millions. It is 2,598,960. So a lot of different choices that you could have. Do you think the numbers would get bigger or smaller if I had 6 cards in my hand? Yeah, it would get bigger. Now, what if I wanted to get all diamonds? Wouldn't that be neat? When you think about diamonds, does anyone know how many diamond cards are in a deck? 13, because each suit has 13 cards. So there are 13 diamonds. So if I'm going to get all diamonds, how many do I have to choose from? 13. 13 of the cards are diamonds. I'm choosing, because the order doesn't matter, 5 of them. We expect there's not that many in comparison hands that would be all diamonds. We would be correct. 1,287 of our hands would be all diamonds. So if you were thinking probability, which you don't have to think probability, but would you agree that's 1,287 out of the 2,598,900? Not a very good chance, is it? But it's there. What if I decided I wanted to be a little bit tricky? 4 black cards and 1 red card. Now, 2 of the suits are black, and each suit has 13 cards. How many black cards are in the deck? 26. So would you agree if I want 4 black cards, that's like 26 cards. I'm going to choose how many of them? 4. And what does the word and mean in this unit? Multiply 1 red card. How many red cards are in the deck? 26. We're going to choose how many of them? 1. So you're going to crunch this in your calculator. And I believe you should get, if you've crunched it correctly, 388,700. But I want you guys to double check that for me. That's what we're getting. Emery, did you check the number? What if I'm wrong, Emery? Okay. Number 3. 3 kings and 2 queens. When you think about cards in the deck, does anyone know how many kings are in a deck? There are 4. So if I want 3 of those, would you agree it's like 4? Choose 3. How many queens are in the deck? How many of those do I want? 2. So 4, choose 2. And then you'd multiply that together. Not a very good chance of this happening. Would you agree it's just 24? It's only 24. Do you guys know what it's called in poker if 3 of the cards are the same and 2 of the cards are the same? It is a full house. It's a 1990s sitcom. We visited the Full House house when I went to San Francisco last summer. It was a little, like a regular person lives there now. And they painted the front door black instead of red. I know. But it does look like it. So, but also nothing was ever filmed there. They just drove up and down San Francisco streets, found a house, filmed the entire opening part of Full House, which includes them at a park that is not across the street from their house. It's just a regular house. And subsequently, somebody owns that house now, and all day long people stop and take pictures in front of it. That would be annoying. They put up signs like no trespassing, and it's a whole thing. But it's still really neat. I definitely fell into the tourist trap. Now here is the combinations trap. 3 kings. And I know what you're thinking. Well, that's very easy, Mrs. Brown, because there's just one thing there. I know there are 4 kings, and I would need to choose 3 of them. But wait. 3 kings, would you agree that's only 3 cards in my hand? So without saying it, but sort of implying it, would you agree that has to be 2 other cards? So 3 kings, you would write and 2 others. And tells me I'm multiplying. If 4 of the cards were kings, how many cards in the deck were not kings? 48, because we had 52, we get rid of the 4. 48, how many of those 48 am I choosing in this scenario? Good, 48, choose 2. So if they don't fill in all the blanks, you have to fill in the rest of the blanks. And I think in this case, you end up with 4,512. Do you think in a multiple choice, they would put the answer for just 4, choose 3? Yeah, tricky. So then you read the next one. 4 aces. Is there a secret unknown part of that one? Because that's only 4 cards. It's 4 aces and 1 other. So I would put and 1 other. Does anyone know how many aces are in a deck of cards? 4. So would you agree this is like me saying, there's 4 of them, I want all 4 of them? How many other cards are there? How many of those do I want? Right, choose one. And so we would crunch this one. It's kind of neat. This one ends up just being 48 ways that can happen. So 48 out of 2,598,960 makes that not very likely that you were going to get all 4 aces, but possible. Now, last but not least, I know what you're thinking. We haven't even done an or question yet today. Best for last. 5 cards of the same suit. Would you agree if we start thinking that could be 5 hearts or 5 or yeah, so this would be one of those scenarios. I'm going to draw it actually down here because I don't have enough space where it could be 5 hearts. I'll draw it like a heart, or 5 diamonds, or 5, what's the little shamrock called? Clubs, or 5, this one's tricky, it's an upside down heart with a little tail. Now, if it's 5 hearts, how many hearts are in the deck of cards? 13. So would you agree this is like 13, choose 5? How many diamonds are in a deck of cards? So this is also 13, choose 5. How many clubs are in a deck of cards? This would also be 13, choose 5. How many spades are in a deck of cards? Come on, guys, 13? But the fact that it could be this or this or this or this, what does the word or translate into? Addition. So that's one of those ones where without saying it, there are the different scenarios you need to add. And I believe if you were to crunch this, I would just do it once and I would times it by 4. I would get 5,148 different scenarios. Do we like combinations? They're almost better than permutations, in my opinion. I want you to practice this. I think I'm going to say about 20 minutes of practice, but then we might start on tomorrow's lesson so I can give you extra time to work because tomorrow I'm also going to send you home with the take-home quiz. Can you what? The test tomorrow. When is your unit test? Thursday next week. Yeah, I know, exciting. And then you'll get a long weekend. You'll get 3 days of maybe no math, but maybe a take-home diploma. And then when you come back, we've got one more. It's the smallest unit of the year. It'll be Trig 2, where we're actually going to review a little bit of Trig, do a little bit more Trig, and then we're into exam review. Sound lovely? Are we excited for the diploma?